Outcome 8, Component 1 is all about solving logarithmic equations. A logarithmic equation contains one or more logarithms. We can use the definition of a logarithm to help us solve these equations. Back in Outcome 7, we talked about how to convert between log form and exponential form, and we're going to use that quite a lot when we're solving logs. So we want to start with recapping how that conversion looks. So if I start with something in log form, and I'm trying to change it into exponential, the first thing I need to do is find my base, which is the small number here. That base becomes the base in exponential form. Then your x and your y switch places, so the y is now your exponent, and this should be equal to x. We're going to do 1 and 3 together, and then we'll have you guys try 2 and 4. So the directions say to write each equation in exponential form. Number 1 gives me log 4 of 16 equals 2. First thing I need to do is find my base. The base in this case is 4, that's the small little number. So I'm going to take that 4 and write it. Then the 16 and 2 switch places. So 2 becomes my exponent, and this is equal to 16. This should be a true equation. 4 squared is equal to 16, so I know I did this correctly. Let's go ahead and look at number 3. I think number 3 looks trickier because it has those parentheses, but the process is going to be the same. So we'll start with finding our base, which is 3, and I'm going to write that. Then all of this in parentheses and the 8 are going to switch, so 8 becomes my exponent, and this is equal to x plus 5. You can keep the parentheses with the x plus 5. You could drop the parentheses. Either one would be okay. Go ahead and take a minute to try number 2 and number 4. Now that we've recapped on how to change between forms, we can move on to solving equations. So the first equation gives me log 36 of x equals 3 halves. Notice that the x is kind of stuck in there with my log. There's a couple different ways that we can solve this problem. So what I want you guys to do is just kind of split your page here, and we'll go through this first one. Okay, so one way to solve this problem, the first thing that I want to do is get this x by itself. I want to isolate the x. So to do that, I'm going to try to change this out of log form and into exponential form. So I'm going to find my base. I think the base is 36, that's the small number. And then I will switch the x and the 3 halves. So the 3 halves will be my exponent, and the x will now be by itself. Now that I've changed it into exponential form, my x is by itself, which is a really good thing, so I just need to do some simplifying on this side. I'm noticing that the base is 36, and that's kind of a large number, so I'm going to break down 36. I know that it's a perfect square, so it can break up into 6 and 6. So instead of 36, I'm going to write this as 6 squared. And I'm putting that in parentheses. My exponent of 3 over 2 is going to drop down, and this is still equal to x. We've learned in previous units that when I have two exponents right next to each other, they multiply together. So I'm doing 2 times 3 halves. What should happen here is that these 2's should cancel, because this is just like 2 divided by 2. So I am left with 6 to the 3rd power. My last step here is to figure out what 6 to the 3rd power is. I'm going to use my calculator by typing in 6. I'll use my little caret button here for my exponent, and then 3. And I got 216. Okay, the other way to solve this problem, the first step is the same. So I'm going to start with changing this from log form into exponential. So my base is 36. The 3 halves is now with the 36, and then this is equal to x. Now technically, because this x is by itself, from here I'm going to type all of this craziness into my calculator. So I'm going to go to my calculator again here. I'm going to type in the 36, and then I'm going to do my little caret. Now, if you have a newer calculator, the exponent should show up there in a little box. That's not too bad. You can just type in 3/2, press enter, and it should give you 216. If when you type in this caret button, you don't get that box, you are going to have to put parentheses around your exponent. So do parentheses first, and then 3 divided by 2, close your parentheses, and then it should give you 216. Again, if you have one of those older calculators, it's not going to quite look like this. I can't show you exactly what it looks like with my calculator, but make sure you put that exponent in parentheses. Either way, we just found that x equals 216. Let's go ahead and look at number 5. So number 5 says, solve each equation. It gives me log 9 of x equals 3/2. So again, we're going to start with changing forms. So my base is 9. X and 3/2 switch places. So 3/2 is my new exponent, and this is equal to x. I'm going to solve this both ways. So I'm going to first do it kind of by hand, and then I'll use my calculator to check my work. 9 breaks down into 3 and 3. So instead of 9, I'm going to write that as 3 squared. I'm keeping the exponent of 3/2, and it's still equal to x. Again, I'm noticing this 2 and 2 in the denominator, so those guys cancel, leaving me with 3 to the 3rd power. 3 to the 3rd power is 27. Okay, if you wanted to save some time and use your calculator, you could, after this step right here, plug in 9 to the 3/2 in your calculator. So I'm going to show you that again. 9, exponent, parenthesis 3 divided by 2, and it still gives me 27. Go ahead and pause your video and try number 6. If you did not get number 6 right, here's the work. You can go ahead and pause your video and check your answer. Okay, example 2, it looks very similar, but this time my log is my base instead of the large number with the log. So I'm going to have to do kind of things a little bit differently here. Okay, the first thing that I want to do is again change forms. So I want to get this into exponential form instead of log form. So I'm going to start with finding my base. My base is x this time, so I'm going to put an x here. And then the 49 and 2/3 will switch places. So the 2/3 becomes my exponent, and this is equal to 49. Now, I think this one's a little bit trickier because just by switching forms, did not get my x by itself. So what I have to do to get x by itself is actually raise both sides of my equation to another exponent. This is going to be weird, but trust me, things will work out nicely. To get rid of this exponent of 2/3, what I'm going to do is raise this entire side to the exponent. It's going to be the same fraction here, but it's going to be the opposite, the reciprocal. So I'm going to take it and flip it upside down and use 3/2, 3 over 2 instead of 2 over 3. If I do that to one side of my equation, I need things to be balanced, so I'm going to do it to this side as well. Now again, exponents right next to each other like this, exponents to exponents are going to multiply. Hopefully you notice some things here. This 2 is on top of the fraction, this 2 is on the bottom, so they cancel. This 3 on top and bottom cancels. So on the left-hand side, I'm left with x. On this side, I'm left with 49 to the 3/2. So again, I have two options when I'm solving this one here. I'll do it the long way first, and then we'll check with our calculator. I can take 49 and break it down. It should break up into 7 and 7. So I could rewrite that as 7 squared. Still have that exponent of 3/2. These 2's again should cancel, leaving me with x equals 7 to the third power. I don't know what 7 to the third power is, so I'm going to use my calculator. 7 exponent 3, and we get 343. Once you are at this step right here, you could kind of jump to your calculator by typing in 49 to the 3/2. So let's go ahead and practice that again. So 49 exponent 3 divided by 2. And again, it tells me my answer is correct, 343. Let's look at one more like that, make sure we got it. So number 7 gives me log x16 equals 4/5. I'm going to start with changing forms. So I have x as my base, 4/5 is my exponent, and this is equal to 16. Now I have again that x with another fraction. So the only way to get rid of that fraction exponent is to use another fraction exponent. Instead of 4/5, I'm going to flip it into 5/4, and I'm going to do that on this side as well. On the left-hand side, the exponents should cancel, leaving you with x. I'm going to take 16 and break it down. I know it can break up into 4 and 4. Ideally, I want it to cancel out with this 4 here, so I would keep going and break these 4s into 2s. So that should give me 1, 2, 3, 4 2s. So I'm going to write that as 2 to the 4th and drop down that 5/4. Again, my 4s cancel, leaving me with 2 to the 5th power, which I can plug into my calculator. 2 to the 5th, and that gives me 32. Again, a nice way to check your answer is using that calculator. You can use it from this step right here. So in my calculator, I'm going to type in 16 with an exponent of 5/4. So 16 exponent, parenthesis 5 divided by 4. And what do you know? It still gives me 32. Go ahead and try number 8. Here's the work for number 8 if you would like to see the process. In your calculator, you would have been typing in this right here. So that's 8 with an exponent of 2 divided by 3, which matches my answer of 4. Okay, we have one last type of problem to go through. These problems are going to look a little bit different because they're going to have logs on both sides of the equation. So when solving logarithmic equations that have logarithms with the same base on each side, you are going to cross off the logs and solve for x. So let's go through the number 9 together. Number 9 says solve log 2 of 2x squared minus 3 equals log 2 of 5x. I'm noticing that both sides of my equation have log 2 on them. So I'm going to go ahead and cross off the log and the base. That should leave me with 2x squared minus 3 equals 5x. From here, I don't have any more logs, so my job is to solve for x. Now I know that this is going to be a little trickier because I'm seeing x squared and x's, and the only way to solve for x when you have that is to factor. So I'm going to try to factor this here. Before I can factor, I need to make sure that it's equal to 0. So I'm going to move this 5x to the other side by subtracting. I'm going to put the 5x right after the 2x squared so that this is in standard form. And now I should be ready to factor. So if you like your factoring blanks, you can go ahead and draw those out. To find the number that I'm multiplying to, I'm going to take my a value, my first number, times my c value, which is the last number. So 2 times negative 3 gives me negative 6. I'm always adding to my b value, which is right in the middle in standard form, so -5. So I'm looking for two numbers that have to multiply to -6, but add to -5. I believe that is -6 and 1. Now this is kind of a trickier factoring one because I had a lead coefficient of 2. If you have a lead coefficient, we said that for a little bit of a shortcut, I could take my two numbers that I thought of and divide by that lead coefficient. -6 does divide by 2. It gives me -3. So that means one of my factors is x minus 3. 1 does not divide by 2. So when I go to write that factor, I'm going to put the 2, the denominator, by the x. So it'll be 2x. And then I can use the positive 1. From here, I'm trying to figure out what x is equal to, so I'm going to take each set of parentheses and set them equal to 0. And then I'm going to solve for x. So to get this 3 over, I'm going to add it. So I get x equals positive 3. On this side, I'm going to start with subtracting 1. Then I'll divide by 2. Now, once I have my two answers, I need to do a little bit of work here to check and make sure that these answers are correct. We learned when we first started talking about logs, we learned that we can never take the log of a negative number. So what I'm going to do is plug both of these things into my one side of my equation and just make sure that it's not negative. I like to use the one that's the easiest, so I'm going to use this log 2 of 5x. So I'll go right here. This is kind of my check. So if I have log 2 of 5, and instead of the x, I'm going to plug in 3. Well, 5 times 3 would give me 15, so I would have log 2 of 15. 15 is a positive number, which means that this is correct. 3 is an answer. Let's check -1/2. So I have log 2, 5. Again, instead of the x, I'm plugging in -1/2. And let's do some simplifying here. 5 times -1/2 is -5/2. And that's a negative right here. I cannot take log of a negative, so this is not a correct answer. You could also use your calculator to help you check. So when I turn this guy on, I'm going to my alpha window 5 to pull up my log here, and I'm going to type in everything that I did to plug stuff in. So my base was 2, and then I did 5 times 3. That gave me a weird answer, but an answer. Again, go to your alpha window 5, 2, 5 times, now I'm checking the -1/2, so -1/2, and it tells me error, non-real answer. If your calculator says non-real answer, it means that this stuff right here would have been negative, and you cannot have a negative. Go ahead and try number 10. Here's the work to number 10, so if you got the answer wrong, make sure you pause your video and try to find and fix your mistake.